5, 4, 3, 2, 1. We have ignition and we have liftoff. We have liftoff of the Titan Centaur, carrying the first of two Voyager spacecraft to extend man's presence farther into the solar system than ever before.
In the late summer of 1977, humanity launched two mechanical messengers into the cosmic ocean. They were not built with the sleek, hyper-advanced digital technology of the 21st century. Instead, they were products of their time, machines born of aluminum, wires, and raw human ambition. Today, decades after their departure, they have achieved what no other human creation has ever accomplished. They have escaped the gravitational cocoon of our sun and entered the uncharted, pitch-black wilderness of interstellar space. Voyager 1 and Voyager 2 are no longer mere instruments of science. They have transformed into our ultimate monuments. They are the furthest outposts of human curiosity. Over 48 years of continuous flight, covering tens of billions of kilometers, these twin trailblazers have reshaped our understanding of the cosmos. Every dazzling ring, every volcanic moon, and every frozen, turbulent atmosphere we know of the outer solar system was first brought into sharp focus by their lenses. It is one of modern exploration's most profound ironies that our deepest understanding of the edge of the solar system comes not from cutting-edge quantum technology, but from ancient machines. The Voyager probes run on onboard computers with less memory than the remote control that unlocks your car. To this very day, their systems rely on 8-track digital magnetic tape recorders designed in the early 1970s. This is the great conundrum of deep space exploration. Because the distances are so vast and the travel times are measured in generations, a spacecraft's technology is already antiquated by the time it finally reaches its most ambitious targets. Yet, despite these limitations, the Voyagers were constructed differently. They were over-engineered for a hostile universe, built by scientists who dared to look past the immediate horizon and prepare for the eternal. When the Voyager project was conceived, NASA was handed a celestial miracle, a rare planetary alignment that occurs only once every 176 years. The last time these giant outer worlds had lined up in such a perfect cosmic queue, Napoleon Bonaparte was ruling France. This unique positioning meant that a spacecraft could visit all 4 gas giants sequentially using minimal fuel. Instead of relying on heavy rocket propulsion, the probes would utilize a revolutionary concept known as a gravity assist. They would literally steal a fraction of each planet's orbital momentum to whip themselves forward into deep space, multiplying their velocity along the way. Originally, funding constraints restricted the mission to a simple 5-year flyby of Jupiter and Saturn. But the engineering team secretly designed the probes with hidden resilience, fervently hoping the mission would be extended. Voyager 1 arrived at Jupiter first in March of 1979, followed closely by its twin a few months later. What they witnessed shocked the scientific community to its core. Before Voyager, humanity viewed the outer solar system as a serene, static graveyard. Instead, The probes revealed Jupiter's atmosphere to be a chaotic, roaring ocean of hydrogen and helium, littered with thousands of counter-rotating storms and violent plumes. But the biggest surprise lay not within the planet itself, but among its moons. Geologists expected Jupiter's moon Io to be a dead, heavily cratered body similar to Earth's moon. Instead, Voyager's cameras caught Io mid-eruption. Blue volcanic plumes shot materials and sulfurous gas 100 kilometers straight into the freezing vacuum of space. Io was revealed to be the most geologically active object in the solar system, twisted and continually melted by the crushing gravitational tides of Jupiter. Meanwhile, its sister moon, Europa, displayed a smooth, bright crust scarred by intricate web-like ice fractures, the first definitive hint that a warm, liquid ocean might be churning beneath its frozen shell. Stealing velocity from Jupiter, the Voyagers pushed onward to Saturn, arriving between 1980 and 1981. If Jupiter was a lesson in atmospheric violence, Saturn was a masterclass in cosmic elegance. The probes revealed that the planet's famous rings were not uniform sheets, but an intricate tapestry of thousands of icy ringlets kept in place by tiny, gravity-bending shepherd moons like Prometheus and Pandora. Yet Voyager also captured ghostly anomalies, dark radial smudges stretching across the B-ring, resembling the spokes of a giant bicycle wheel. These features defied the classical laws of gravitational mechanics. To this day, scientists believe these spokes are formed by static electricity, levitating microscopic dust particles above the main plane of the rings. At Saturn, the twins reached a crossroads. Voyager 1 was directed to execute a close flyby of Titan, Saturn's largest moon, discovering a thick, nitrogen-rich atmosphere choked with organic smog, an environment resembling a frozen primordial Earth. This specific trajectory, however, bent Voyager 1's path sharply upward, flinging it out of the ecliptic plane and putting an end to its planetary encounters. Its future lay solely in the empty dark. Voyager 2, however, received a flawless gravity assist from Saturn that propelled it onward toward the outer limits of our solar system. It would carry the torch alone, embarking on the first and only visitations to the enigmatic ice giants at the edge of our sun's reach. In January 1986, nearly a decade after leaving Earth, Voyager 2 made its closest approach to Uranus. What it found was a world of stark deviations. Unlike the turbulent, expressive visages of Jupiter and Saturn, Uranus presented a serene, completely featureless aquamarine cloud deck. But beneath this calm exterior lay a planetary puzzle. Uranus's magnetic poles were not aligned with its rotational axis. They were tilted at an astonishing 59 degrees. As the planet spun on its side, its magnetosphere wobbled chaotically through space, creating a turbulent magnetic tail that defied all conventional planetary models. Voyager 2 also flew past Miranda, Uranus's smallest inner moon. The images sent back revealed a chaotic patchwork of geological terrains, vast canyons plunging 20 kilometers deep, oval racetrack-shaped ridges, and terraced cliffs where ancient and young terrains sat violently juxtaposed. Miranda looked like a moon that had been shattered into pieces by a colossal impact, only to be sloppily re-aggregated back together by gravity. Three years later, in August 1989, Voyager 2 reached its final planetary destination, Neptune. Situated 30 times further from the Sun than Earth, scientists expected Neptune to be a frozen, sluggish world devoid of energy. Instead, Voyager discovered a dynamic, fierce environment. Methane gas in the atmosphere gave the planet a deep royal blue hue, whipped by the strongest winds ever recorded in the solar system, reaching speeds of up to 2,400 kilometers per hour. At Neptune's northern pole, the probe dipped within just 5,000 kilometers of the cloud tops before capturing images of Triton, Neptune's largest moon. Triton was a frozen kingdom of nitrogen ice caps, yet its surface was alive with active cryovolcanoes, spewing plumes of liquid nitrogen and dark dust into a razor-thin atmosphere. With its flyby of Triton complete, Neptune's gravity bent Voyager 2's path downward, sending it plunging into the southern skies. The grand tour was officially over. The planetary cameras were turned off, and both probes set their sights on the edge of the solar system. As the Voyagers traveled further from home, their missions evolved. They were no longer photographers. They were cosmic cartographers, mapping the invisible boundaries of the Sun's kingdom. Our Sun is not just a source of light. It blows a constant, supersonic gale of charged particles out into space, the solar wind. This wind inflates a giant magnetic bubble called the heliosphere, shielding the planets from lethal cosmic radiation. But as the Voyagers traveled billions of kilometers past Neptune, they entered the termination shock, the violent region where this solar wind suddenly slams into the dense, icy resistance of the interstellar medium. Here, the Voyagers made an extraordinary discovery. The boundary was not a smooth, clean line. Instead, as the solar wind compressed against the interstellar wind, it crumpled into a chaotic, foam-like sea of magnetic bubbles. The edge of our solar system was a constantly fluctuating, turbulent battlefield. On August 25, 2012, Voyager 1 crossed the ultimate threshold, the Heliopause. It became the first human-made object to leave the solar bubble and enter interstellar space. 6 years later, Voyager 2 joined its twin, crossing into the interstellar medium at almost the exact same distance, 120 astronomical units from the Sun. When they crossed, their instruments registered an 80-fold spike in the density of surrounding plasma and a torrent of galactic cosmic rays. Yet, to the utter bafflement of NASA scientists, the probes detected no change in the direction of the ambient magnetic field. According to every theoretical model, the magnetic orientation should have shifted completely once the probes entered a realm dominated by other stars. The universe had refused to conform to our math, proving the unmatched value of sending physical machines out into the field to test our assumptions. By the 2020s, the Voyager probes had become old, fragile ships sailing through an incredibly hostile environment. Their nuclear batteries, powered by the decay of plutonium-238, were steadily losing strength, forcing NASA to systematically shut down their onboard science instruments and heaters to conserve every scrap of electricity. In May 2022, Deep Space controllers received a chilling transmission from Voyager 1. The telemetry data, the vital status updates detailing the spacecraft's health, had turned into complete gibberish. It was a chaotic stream of repeating zeros and nonsensical numbers. Yet, strangely, the probe's scientific data remained perfectly intact, and its radio signal stayed strong. Imagine receiving a letter from a close friend. The address on the envelope is perfectly correct, and the mailman delivers it right to your door. But when you open it, the letter is written in a bizarre, unreadable language. Even more concerning, Voyager 1's emergency safe mode routines had not triggered. The spacecraft genuinely believed everything was operating flawlessly. For 4 agonizing months, engineers at the Deep Space Network engaged in a slow-motion game of tech support across a 24 billion kilometer void. Because of the vast distance, a command sent from Earth took 22 hours to arrive at the probe, and engineers had to wait another 22 hours to hear back. With a delicate sequence of commands, NASA instructed the probe to reset its memory and use the primary system again. The gibberish vanished. Through patient deduction, they discovered the culprit. A cosmic ray had corrupted Voyager 1's attitude control computer, causing it to route its data through an old, physically degraded backup system that scrambled the output. A similar crisis struck in late 2023 when the flight data subsystem corrupted its memory, taking nearly 7 months to resolve. Then, in July 2023, a mistaken command caused Voyager 2 to accidentally tilt its antenna just 2 degrees away from Earth, severing all communications instantly. The probe was deaf and blind in the dark. In a desperate bid, NASA utilized the Deep Space Network facility in Canberra, Australia, to send a high-powered interstellar shout into the void. 37 hours later, a faint whisper returned. Voyager 2 had heard the cry, reoriented itself, and come back to life. In February 1990, just before Voyager 1's cameras were powered down forever to save energy, the legendary astronomer Carl Sagan convinced NASA to turn the spacecraft around for one final look backward. From a distance of 6 billion kilometers, Voyager 1 snapped a photograph of its birthplace. The image became known as the pale blue dot. It showed our entire world as a solitary, microscopic speck of dust suspended in a sunbeam. It was a profound reminder that every king, every peasant, every war fought, and every dream chased in human history had taken place on that single, fragile pixel. It underscored our collective responsibility to cherish and preserve the only home we have ever known. The final act of the Voyager mission is rapidly approaching. By the late 2020s or early 2030s, the radioactive heat sources within both probes will fall below the critical threshold required to run even a single instrument. Their transmitters will go dead, their internal heaters will freeze, and the twin pioneers will fall completely silent. But their silence does not mean their demise. In about 300 years, Voyager 1 will enter the inner edge of the Oort cloud, the vast shell of icy comets surrounding our solar system. It will take another 30,000 years to exit the cloud entirely. Long after the sun has consumed the Earth, long after human civilization has faded into the memory of time, these two small, silent titanium crafts will continue to drift pristine through the vacuum of the Milky Way. Secured to their hulls are the golden records, gold-plated copper phonograph discs containing greetings in 55 languages, the songs of humpback whales, the crying of human infants, and the timeless melodies of Mozart and Chuck Berry. They are message bottles cast into the cosmic ocean. Today, decades after their departure, they have achieved what no other human creation has ever accomplished.